All right, and welcome back. So today we are going to be talking about another type of pattern, and it's going to be called a geometric sequence. Last time we talked about arithmetic sequences, and today we're going to be talking about geometric sequences. They're similar, but they are different. So today we're going to be going through what differentiates between an arithmetic sequence as well as a geometric sequence, and how we can use our geometric sequences to find the nth term in a sequence. So here we go. So just a quick do now. What is the next term in this sequence? 2, 4, 8, so on and so forth. What is going to be that next term? Well, you might look at it and say, okay, 2 plus 2 is 4, but 4 plus 4 is 8, so there isn't a common difference between them. But if I multiply, I can do 2 times 2 to give me 4, 4 times 2 to give me 8, so then our next term is going to be 16. Because 8 times 2 will give us 16, right? But what if I ask this question? What are the next 3 terms in this sequence? I'm starting with 1024, then 256, then 64. And here we can see the numbers are getting bigger, right? We're starting with a 4-digit, then a 3-digit, going down to a 2-digit. So we're dealing with bigger integers here. But you might be able to determine what the next 3 terms are going to be. Well, 1024 to 256, if it's a sequence, there should be a pattern. You might not be able to tell what that pattern is, but 256 to 64, well, it looks like we're dividing by 4. So if it's a sequence, it should be the exact same thing. So we have to take 64, divide that by 4. And we get 16. We take 16, divide that by 4. We get 4. Take 4, divide that by 4, we get 1. So the next 3 terms would be 16, 4, and 1. Pretty good so far, right? Pretty good. So again, the essential question is, how can you use a geometric sequence to describe a pattern? And here's the core concept. So please copy down the notes, pause the video, and then resume when you're ready to hear it out. So for a geometric sequence, the ratio between each pair of consecutive terms is the same. The ratio is called the common ratio. Each term is focused by multiplying the previous term by the common ratio. Now, real quick, if we go back to this example here, we were dividing by 4. Right? So were we really multiplying? Yeah, we were. Remember, if we're dividing by 4, that's the same as multiplying by 1/4. Okay? So when we're dividing by a number, we're really multiplying by its reciprocal. So going back to this concept, in this sequence here, they have 1, 5, 25, and 125. The common ratio is going to be 5, right? That common ratio is going to be 5 because it's occurring through multiplication every single time. Now, this is good, but what if we want to put it into a formula? Well, in here, this is going to be our formula or our equation for a geometric sequence. So we have a sub n. We also sometimes might see that as t sub n. So we might see it as t sub n, meaning the term, okay? Be the nth term of a geometric sequence with the first term, a1. Again, we might see it as t1 sometimes. And common ratio r. The nth term would then be given by this formula. So if I want to find what the nth term would be. So this is the nth term. I then take it and use my first term and multiply it by the common ratio. And then I bring it to the power of n minus 1. Now, we might see it as a sub n is equal to a sub 1, times r to the n minus 1. We also might see written as t sub n. So I wanted to put it both out here because sometimes they want the term, so the t stands for term. Some ask for a, some ask for t. It's the same thing, 6 to 1, half a dozen the other. All right, so great job so far. Let's put it into practice. But real quick, let's decide whether each sequence is arithmetic, geometric, or neither, and explain your reasoning. So try it out the best you can, pause it, and then resume when you're ready to hear my explanation at least. All right, so in here, for A, we have 120, 60, 30, 15. The way that I do it is I say, okay, if I go from 120 to 60, what happened? I subtracted 60. I also divided by 2, right? Or we want to be a little bit fancier. Okay, we also multiplied it by a half. We want to see which of these two, the green or the red, is going to be in the next set. Well, from 60 to 30, I subtracted 30, but I still multiplied by a half. So since I'm multiplying by a common ratio, this is going to be geometric. Because I have a common ratio. I'm going to say that r is equal to 1/2. All right, over on B, we have 2, 6, 11, 17. So let's see what happens here. So from 2 to 6, I added 4, and it looks like I multiplied by 3. From 6 to 11, I added 5, which doesn't match here, and I multiplied by what? I didn't multiply by 3 either, right? I'm multiplying by a completely different number, right? I'm actually multiplying by 11 over 6. And neither of these match up, so this is going to be neither. Because there's no common difference or ratio. So this is actually going to be neither. All right, sweet. Nice job, nice job. Let's keep it going. Okay, decide whether the sequence is arithmetic, geometric, or neither. Explain the reasoning. So pause the video, attempt these 3 problems, and when you're ready for the answers, resume. All right, so here are the answers for those 3 problems. The first one is going to be arithmetic. The common difference is -4. The second one is going to be geometric. The ratio is 1/8. And the third one is going to be neither. There's no common difference or ratio. All right, cool. Sweet. Let's keep it going. Write the next 3 terms of each geometric sequence. So the first thing you want to do with these is you want to establish what that common ratio is. What is that r? So if I'm going from 3 to 6, I multiply by 2. 6 to 12, I multiply by 2. So r is going to be equal to 2. So that means I take 24, I double it, I get 48. I take 48, I double that, I get 96. I take 96, I double that, I get 192. Those are the next 3 terms of that geometric sequence. Now B's a little bit trickier. I'm seeing that my numbers are decreasing here. So I'm multiplying by a fraction, or I'm dividing. So I'm going from 64 to -16. So I'm multiplying by -1/4, or I'm dividing by -4. And we can see that that pattern continues because a -16 to 4, well, 4 is positive now, so I have to be going by a -1/4. So if I'm at -1, I multiply that by -1/4, and I get 1/4. I then take 1/4 and multiply by -1/4. I get -1/16. And then I do it once more, and I get 1/64. Sweet, cool. Cool. Nice job. So in this problem, it says write an equation for the nth term of the geometric sequence, 2, 12, 72, and then find a sub 10. So the first thing we want to do is always write out our formula or our equation. it's a sub n is equal to that first term times our ratio to the n minus 1 power. Well, I want to find a sub 10. My first term is going to be, oh, I missed it. It's going to be 2. I want to find that common ratio. So from 2 to 12, I have to multiply by 6. So r is going to be 6 to the 10 minus 1. So I get a sub 10 is equal to 2 times 6 to the 9th power. And now we just take out our calculators. 2 times, I like to put parentheses, 6 caret 9. Woo, that is one big old number. Okay, here we go. 201. 55 392. So 20,155,392. As you can see, with geometric sequences, we get really big numbers or even really small numbers. I recommend to, again, use the caret button and use your parentheses. That way it's just easier for you to figure it out. Okay? Sweet, sweet, sweet. Nice, nice, nice. Here we go. I want you to try these on your own. I'm going to recommend that when you are working with fractions, use the ABC button if you have a scientific calculator. It's going to be the button that looks like this, where it's A, B, C. Use that when you have a ratio that is a fraction. So for example, if you had, I don't know, 2 times 1/2 raised to the 5th power, let's just say. What you would want to type in is 2 times parenthesis 1, then that ABC 2 caret 5. That way when you plug it in, you're going to get a fraction and you're not going to get a decimal, because these decimals can be very, very, very tiny. So we want to be precise with this, so we want to use fractions. That, again, that's if you have a scientific calculator and you have the ability to use the ABC. You also can just distribute the power inside. So I could send that 5 to the 1 and that 5 to the 2 as well. So it would ultimately become 2 times 1 to the 5th over 2 to the 5th. Okay, and then from there you can just simplify down. This actually would be 1 over 2 to the 4th, 2 to the 4th, 2, 4, 8, and 16. So this would be the answer that we would be looking for. If you had this as a decimal, it's gonna be a long decimal. So try and be as precise as possible and use that ABC button, or just do it out, just like I did by sending the exponent into the fraction. All right. So again, pause the video, attempt these 4 problems, and then the next slide is going to be the answers. All right, so here are the answers. Again, as you can tell, for 10 and 11, I use the ABC button. That way we have a fraction. Okay, you also can just work with it as your exponent rules. For 11, you get 976 and 9/16. If you have it as a improper fraction, it's 15,625 over 16. Great job, folks. If you have any questions, please feel free to reach out. I'm so proud of you. Keep up the great work and have a nice day.